steps up for you guys, for those of you guys that love steps. The first thing we're going to do is we're going to read calculus. Okay, we're going to identify numbers and we're going to identify the relating equation. Okay, that's the first two steps. Then we're going to do some calculus. That's taking the derivative, and then we're going to be doing algebra and trig, whatever it is that we need to do in order to simplify and find our answer. So,
Without further ado, let's go.
we got two cars are driving towards an intersection from perpendicular directions. Okay, so let me draw a little quick picture here. This is a common problem. Okay, we have a road here at an intersection. Okay, we have two cars driving towards each other in perpendicular directions. The first car's velocity. Okay, we gotta have cars here. Let's draw a car. Let's go with this car right here. Okay, he's going this way. His velocity is 10 meters per second. So let's call this car A. No, wait, do I want to do that? Okay, we'll just write 10 meters per second. Okay, and then we have another car, velocity at 6 meters per second. Now they're driving in a perpendicular direction, so let's put that car over here. And he's going this way, and his speed is 6 meters per second. Okay, cool. At a certain instant, the first car, okay, I want to say first car is, let's just do car sub 1. Is that good? So C sub 1 is having a speed. Let's go dc sub 1 over dt. Its speed is 10 meters per second. And then the second car, dc sub 2, over dt is 6 meters per second. Okay. All right. So we identified this number and this number. Okay, we're good. At a certain instant, the first car is 4 meters from the intersection. Okay, so we're going to have a distance here. Let's say this right here. Okay, this distance is 4. Okay, so C sub 1 at a certain instant. So I'm going to say T naught for the certain instant. It is a distance of 4 meters away from the intersection. And then we have the other car, C sub 2, at a certain instant. That car, it, is 3 meters from the intersection. Okay. So we have a distance right here. We'll say from here to here is 3. Okay, cool. What is the rate? Okay, we identified those two. Okay, we identified all the numbers that we see, right? And we have a cute little picture to help us understand it. Sweet. What is the rate of change of the distance between the cars at that instant in meters per second? Now, the distance between the cars. Okay, I'm going to bust out a different color just because this is kind of weird right now. The distance between the cars would be this guy. The hypotenuse of this right triangle. Okay, so the distance is what we're looking for. Actually, the rate of change of that distance. So let me draw that triangle really quick. That's essentially what we're using here. We have the distance. I'm just going to say D for that one. And this is going to be C sub 1, and this is going to be C sub 2. We know right now at this instant that C sub 1 is 4, C sub 2 is 3. Okay, we don't know this D. We can find it, but we don't know that distance right now. Okay, so the cars... This car is driving this way, right? He's going this way. And this car over here is driving this way. So what's happening to these numbers right here? What's happening to my numbers? These numbers are getting smaller, right? Okay, so now we have to fix something on our rates. You see our rates right now? They're both positive, but they are decreasing the distances, and so we need to make these into negative rates, which is kind of weird. It's kind of like something you have to like think about. It's like embedded in this question. It doesn't obviously tell you that these are negative rates, okay? But they are negative rates in relationship to these distances. In relationship to the car, it's not a negative rate, but to the distances, it is a negative rate. So they are negative rates. So how are we going to find... What are we going to look for? We're looking for d over dt. Okay, at this instant. So when t is t naught, what is that? Okay, so man, that was crazy, guys. Let's just take a pause here and realize what we just did. We did this step and then this step, and that was hard. That was really hard. Trying to understand this calculus question, this scenario, that was difficult. Okay, next we're gonna do step 3. Oh wait, we didn't even do step 2. Really, we don't have the relating equation. Oh, but it should be obvious to you guys. Once you guys see this triangle right here, and you see the relationship between these two numbers, right? Right? What's our relating equation, guys? Do you know? Do you know? Do you know? If you said d squared equals c sub 1 squared plus c sub 2 squared, then you were right. Notice that I didn't put in the numbers 3 and 4 yet. And the reason why I didn't put those in is because if I did put the 4 in there and I did put the 3 in there, the equation sees those as constants now. But I need to make sure that those numbers, the c sub 1 and the c sub 2, are not seen as constants. They have to be seen as changing numbers. So now what I'm going to do is I'm going to take the derivative with respect to t to see what we get. So the derivative of d would be 2d, then dd over dt. The derivative of c sub 1 would be d c sub 1, oops, 2 c sub 1 d c sub 1 over dt. I don't know. Maybe you guys don't like the sub numbers. I should have used a and b, but oh well. Next one is 2 c sub 2, and then d c sub 2 d sub or dt. Okay, so we identified the relating equation. We just did our calculus. That's this part right here. Okay, did our calculus. Calculus is done. Sweet. Now we have to do algebra and trig. Now what we're going to do is we're going to look for dd over dt, the change in the distance between the two cars. Oh my goodness, this is nuts, guys. This is nuts. So we need to know this number, 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 and we need to know this number. Actually, this is the number we're looking for. So we only need to know 1, 2, 3, 4, 5 other numbers. Do we know what those numbers are? Heck yeah, we do. C sub 1 is 4 at this instant. Booyah. C sub 2 is 3 at this instant. Booyah. We know what C sub or dc sub 1 of dt. That's the rate. That's negative 10. Booyah. And then there's dc sub 2 over dt. That's negative 6. Oh, snap. We need to know what d is. Man, I wish there was a way we can figure out d. There is, Mr. Patey. Okay, weird voice. What are we going to do? We're going to take this relating equation and plug in what we know. D squared equals 4 squared plus 3 squared. Okay, so the c sub 1 is 4 and the c sub 2 is 3. And so let's solve that. D squared equals 16 plus 9. 16 plus 9 is 25. So that means D equals 5. So I'm going to put 5 right there. Oh, man. Mr. Petty, this is hideous. All right, let's simplify this up. Let's make it look a lot prettier. You can't make that look pretty. Well, you made your face look pretty. I'm just joking. Just joking. Don't take offense. We have 8 times negative 10. That would be negative 80. Wow, that's not that bad. And then we have 2 times 3 times negative 6. That would be 2 times 3 is 6. And 6 times negative 6 is going to be negative 36. And so we have 10 dd over dt equals negative 116. I'm hoping that I did my mental math there correctly. I'm just going to double check really quick. Yep, okay, we're good. Okay, next we're going to divide both sides by 10. Oh, dang. dt equals negative 116 divided by 10. All right, now when you divide by 10, you just move the decimal over 1. So this is actually negative 11.6, negative 11.6. There you go. We found our answer. Hey, it's not asking me for the units. We should know the units here. It's meters per second, right? Because the d is a distance. So it's just meters and then per second because it's a rate. All right. That's it.